Hi everyone, this time we are going to talk about pressure, density, and fluid as we begin chapter 11. And the topic for this video is going to be density. Density is something that you woke up this morning understanding. You understand low density things and high density things. Low density things are things like styrofoam, clouds, feathers, bubbles. High density things, gold, lead, bricks, things that have a lot of matter stuffed into a very tiny space. Density is defined as mass per unit volume. And if you have a volume of something and it has very few molecules in it, it is going to be a low density substance. Lots of molecules crammed into a very tight space, it's going to be a high density substance. The equation for density is going to be equal to mass divided by volume. And the symbol used in physics for density is Greek letter rho, R-H-O, and it kind of looks like a soft P. If you have had density in chemistry classes or in your high school or your other courses, you may have used D for density. You do whatever works for you, but you're going to see in the textbook, and I'm going to use rho for density. Now there's two sets of units that are common, the sets of units used in chemistry, and if you recall, chemists use the CGS system of grams, centimeters, and seconds because they're talking about small quantities that they can put in a beaker. In physics, we have a tendency to use the big units of kilograms, meters, and seconds, and so when we're talking about density, our units are going to be kilograms per cubic meter, kilograms, and volume is going to be in cubic meters. And to remind you, a cubic meter is 1 meter high, 1 meter wide, and 1 meter deep. This is sort of like the size of a child's playpen, or the amount of space that's occupied by one large major appliance, like a chest freezer. A cubic meter is a lot of space. So as we look at numbers, just don't be bamboozled if you go, holy moly, that's a big number. Well, yeah, because that's a lot of volume. When you're talking about densities, there's always going to be a density table, whether you're looking at the one in the textbook or on the constant sheet that I've given you for the course. And a lot of these things are going to have odd or funny sort of units at the top. So I want to take a minute and look at these. Now, for the substances that are listed here, the units are grams per milliliter. And as you know, a gram per milliliter is the same as a gram per cubic centimeter. But in physics, we're going to use kilograms per cubic meter, and having to convert all the time will just be work. Fortunately, there is an easy fix. In order to go from grams per milliliter to grams per cubic meter, multiply whatever number is here by 10 to the third. So for example, if you look at lead, the density is 11.3 grams per milliliter, but if I go times 10 to the third, I now have it in kilograms per cubic meter. Petrol or gasoline is 0.68 grams per milliliter, or times 10 to the third kilograms per cubic meter. Once you realize this, it'll save you lots of converting time. Now, density is unique to individual substances. It can be used to identify what substance you've got and the purity of that substance. Back in the gold rush days of California, miners would bring their gold into an assay office, and in that assay office they would do some simple chemical tests, some simple density tests to determine the purity or the quality of their gold. The density of water is 1 gram per cubic centimeter or 1 gram per milliliter. One more time, this is an example of the fact that the metric system is based on the number 10 and the compound water. And this is a piece of information you should know or have written down on your formula sheet. This also translates into water being equal to 1 kilogram per liter. Liter, remember, is also a unit of volume. So if you have a liter of water, you have like a 1 liter beaker of water, the mass of the water in there is going to be 1 kilogram. Or if you have a 2 liter bottle of soda, the 2 liter bottle of pop is going to have a mass somewhere in the neighborhood of 2 kilograms. Now, density is affected by atmospheric pressure, and temperature. So these densities are given at STP, if you've ever had chemistry, standard temperature and pressure, 1 atmosphere, and about 25 degrees Celsius. Liquid water is most dense at 4 degrees, positive 4 degrees Celsius, and that's going to be useful next chapter when we start talking about heat. We'll go into some demonstrations there. So here's something for you to think about. As water density gets warmer, as water gets warmer, is it going to have a higher or a lower density? So if you think about it, you've got molecules in a substance that are bonded together. And this is just a generic pair of molecules, and I've got a little spring drawn for their bond. As it gets warmer, they're going to oscillate more. They're going to vibrate more. And as they vibrate more, they're going to vibrate further and farther from their rest position. And what that's going to translate into is an increased volume. Well, if density is mass per unit volume, if the volume is going to go up and it's down in the bottom for the same amount of mass, the density is actually going to go down. The best example for me, in my mind, is when I start thinking about ponds in the summertime. If I go swim in a pond, and I have a pond in my backyard, love my pond, if I go out there early spring, early summer, and I jump into it, the layer of warm water is very, very tiny at the top, and there's a lot of cold water down below. And I try and, keep most of my body in the warm, but my little toes are going to be down in the cold. As the summer progresses, that layer of warm water gets thicker and bigger because of the fact that the sun up above is actually heating this water, and the cold water sinks to the bottom. And over the winter, the heat is lost by the pond, and you start the next spring with the process all over the place. But again, the warm water, less dense, and so it's going to be on top of the cold water, which is more dense. We care a lot about density of fluids because we care a lot about floating and sinking when we start talking about density. Anything with a density less than 1 gram per cubic centimeter is going to float on water. Everything from rubber duckies to logs that are sent downstream in the timber industry. Anything with a density bigger than 1 is going to sink, rocks and coins dropped in the ocean and things like that. So what's going on here? It's an interesting density situation. This is a container of water. We have sugared soda and we have diet soda. And this is a common demonstration that is done in a face-to-face class when you're talking about density. It's exactly the same amount of volume, so the volume of each is going to be the same, but it is obvious that the density of the diet pop is going to be less, and the density of the sugared pop is going to be more because of the fact it's sinking. Well, what's going on here? Well, soda pop consists of water, plus there's bubbles, there's carbonation, there's carbon dioxide gas that's also trapped inside that can. Diet pop with the flavorings and the artificial flavorings and things like that, it still has a relatively small mass. You take sugared pop and it, besides water and carbonation, it also contains sugar molecules. This is a picture of a sugar molecule, big, honkin', massive molecule. And because there's so many of these big molecules inside of this can, it makes it have a huge mass, bigger density, and it floats, sinks in water. Now, the density of a person is on average about 0.985. So do people sink or float? Well, it also depends on the person. I threw this chart in just for giggles. Hit pause if you want to take a close look at that. It all depends on the amount of body fat, and as we get older, hate to break the news to everybody, but as we get older, we tend to have more body fat. When my husband was very, very young and very, very lean, he used to annoy his Fayette instructors by sitting on the bottom of the pool because he was so lean, had so little body fat, that his density was actually bigger than water, and so he was a sinker, not a floater. He can't do that anymore. Let's talk about specific gravity. When you talk about density, you're also going to hear somebody talk about specific gravity. Specific gravity is actually a ratio, and it is the ratio of the density of a substance compared to the density of water. Because it's a ratio, it is unitless. So why do we even bother? So often we care if something is going to sink in water or if something is going to float relative in water. And specific gravity is just one number to tell us if something is going to be a floater or a sinker or how much in between. So if we want to calculate the specific gravity of like ethyl alcohol or ethanol, it's the density of the substance divided by the density of water. So density of ethyl alcohol is 0.79 grams per milliliter. Density of water is 1 gram per milliliter. Anything divided by 1 is itself, and the units cancel. So that's going to be the specific gravity of ethanol. And since this number looks so close to that number, you say, why do you bother? Well, you bother because this is used in so many different industries just to determine if something is going to float or sink. So let's use this information to answer a question important to many college students. If I want to make a mixed drink, which do I add first, the mix or the alcohol? Let's take a look at it. If I put in a glass, let's say I'm going to make a rum and coke, and do I put the alcohol in first with a density of 0.79, and the mix, let's say it has an a density of 1, like water, or do I do it the other way and put in the water at the bottom or the mix at the bottom and then the alcohol 0.79 on top? If I want it to be self-mixing, which way do I do it? Yeah, this way. Because if I have the low density thing on the bottom, what's going to happen is it will all by itself, it's going to mix. If you do it the other way around and put the alcohol on top, boy, honey, your first couple of sips are going to be pretty exciting, or you're going to need a swizzle stick. Where else is specific gravity used? Lots of different things. It's used in automobile testing for radiator fluid and battery fluid. If you take a car battery to know if it's charged or not, you can look at the concentration, the salt concentration of the battery fluid. And there's gizmos like this. You suck some battery fluid up. There's some little floaty beads in there. Depending upon where they float, you read right off of the little hydrometer if it is going to be a good battery or it needs a recharge. People who are brewmasters or are making alcohol in some sort of a distillery, what they can do if they want to know if their crop is done is they will take a sample, put a hydrometer in it, and all a hydrometer is it floats, and where it floats is a quick way to measure specific gravity. If it floats at the right spot, it knows that the maximum alcohol content is there, and they know it is done fermenting. If you go to the doctor and you have to submit a urine sample, one of the many tests they're going to do is put a hydrometer in there, which is a little floaty thing. It has a little scale here, and the bottom is just weighted, and it's completely encased, so it's sterile, of course. And where it floats measures your specific gravity. If your specific gravity is too high, it might be an indication that you are dehydrated or an indicator of certain kidney challenges. If your specific gravity is too low, again, it might be an indicator that maybe your kidneys are not pulling salts out of your urine. So it's one of the multitude of tests that are done. All right, that will do for this time. We're going to come back next time and do a math problem. See you then. Bye.